Here's example 3 with graphing simple types of cosine or sine functions. So here what we want to do is graph y equals cosine x and y equals cosine 2x together on the same set of axes so that we can see how they relate to each other. Okay, so again, this is just cosine 2x, so it's not really anything overly complicated, so we can just sort of treat it the same way that we treat other types of functions that we talked about in pre-calculus, things like that. So remember, well first let's graph this y equals cosine of x. So we'll put that on a graph first, then we'll talk about what this does. So we'll set up our x-axis here. Oh, and just like in the other examples, if you want to follow along with some graph paper, but you don't have any, check the video description here, and there will be a link. You can click the link, open up some graph paper and print that out if you want to follow along. Okay. So x-axis, y-axis. Okay, so let's put -1 down here, +1 up here, and then this will be pi over 2, pi, 3 pi over 2, and 2 pi. And then keeping the same scale, this will be -pi over 2, -pi, -3 pi over 2, and -2 pi. Okay? Okay, so now let's graph the cosine function. So we know it goes through 0, 1 up here, so we talked about its general shape in a separate video earlier. And we come down through here, go through here, up through here, and through here. And then it continues on this way. And it goes through here. Okay, so there's y equals cosine of x. Okay. So now what does this 2x do? So remember, if you multiply x by 2, so remember when you do stuff to x, it kind of works backwards from how you might think, so that's a pre-calculus thing there. So if we multiply the x by 2, then what's going to happen is the graph is going to get squished in. Okay, so you might think, oh, I'm multiplying x by 2, so maybe it's going to stretch it out. But remember, when you multiply x by some number like this, it's actually going to squish it in by a factor of 2. Okay, so we're taking x, multiplying it by 2, so this gets squished in by a factor of 2. So in other words, all the x coordinates are going to get divided by 1/2. Okay, so here now we have to be kind of careful with the grid. So this is pi over 2, this is pi. Every 2 grid marks represents pi over 2 units. Okay, so half that's going to be pi over 4. Okay, so I guess that doesn't really matter too much though, but all we have to do is just take this and compress it by a factor of 2. So in other words, just take this x-coordinate divided by 2. That's going to put us right here. Okay? Then we take this x-coordinate divided by 2. That's going to put us over here. Okay, so this is an x-coordinate of pi. Okay, so this is the point pi, comma, -1. Okay, so what's going to happen is when we graph cosine of 2x, this point is going to become pi over 2, comma, -1. Okay, pi over 2, comma, -1. Okay. So remember, when you multiply x by 2, everything actually gets squished in by a factor of 2. So this pi over 2, comma, 0 actually becomes pi over 4, comma, 0. Okay? And 0, comma, 1 stays 0, comma, 1 because 0 is the x-coordinate. If you divide it by 2, you still get 0. Okay? So this point's still here. This point becomes this point. This point over here becomes this point. 3 pi over 2. That's going to get divided by a factor of, or it's going to get divided by 2, so it becomes 3 pi over 4, but that's going to be over here. Okay. So this point becomes this point right here. Okay. And 2 pi, comma, 1, okay, divide the x-coordinate by 2, that's going to become pi, comma, 1. Okay, so again, it's just a pre-calculus thing we're doing here, so remember, when you multiply x by 2, everything's going to get squished in horizontally by a factor of 2. Okay. So this is going to be like this now. So we're just taking a pre-calculus concept and applying it to this trig function here. Okay, and we'll continue it over here. So this is y equals cosine of 2x. Okay, now we also want to extend it the other way. So the same thing's going to happen over here. So there's 2 ways we can think of it. We can do the same thing with dividing all the coordinates by 2, all the x coordinates by 2, or we can remember, oh hey, it's an even function, right? So we can just reflect it over the y-axis. But we do have to be careful with the whole even function thing, because when you do these transformations like this, you may end up with something that's not an even function. This still is even, so that's okay. But anyway, the most general thing that, or the safest thing to do would just be to keep doing it the same way. So take all the x coordinates divided by 2. So this negative pi over 2 comma 0 becomes negative pi over 4 comma 0. Negative pi comma negative 1 becomes negative pi over 2 comma negative 1, because the x coordinate gets divided by 2. Okay, so again, this 2 means we take all the x coordinates and divide them by 2, not multiply but divide. Okay. And again, that's just a pre-calculus thing. So what next? Negative 3 pi over 2 comma 0 becomes negative 3 pi over 4 comma 0. Okay, we're just take this distance here, okay, and half of that distance is going to put us over here. Okay. And then negative 2 pi comma 1 becomes negative pi comma 1. So again, divide the x coordinate by 2. And we end up with something kind of sort of like this. Okay, so try to make it a rounded corner. All right. Okay, so that's what we have here. So it looks kind of cluttery, but so this longer one here, that's cosine, okay? And then if we do cosine of, that's just plain old cosine of x. So then if we do cosine of 2x, that's going to take that graph and squish it in by a factor of 2. So in other words, take all the x coordinates and divide them by 2. And then that's what we're going to get here, okay? So that's example 3 with graphing simple types of transformations, okay? So another example coming up in the next video, and then we'll talk about more complicated types of transformations a little bit after that.